Hi, today we are going to talk about the origin of mass. First, we need to know about some things called the fundamental particles. So you thought the atom was small? Turns out that the atom is made up of protons, neutrons and electrons. And while the electrons are fundamental particles, the protons and the neutrons are made up of fundamental particles called the quarks. In total, there are 17 such fundamental particles. And these particles cannot be broken down further and are like the building blocks of our whole universe. Now, the question becomes, how do these particles get their masses? So imagine this invisible ocean-like field called the Higgs field. As a particle moves through this field, it gains its mass. Think of it this way. Say you have to travel from point A to point B in a city. Now imagine yourself as a fundamental particle and the city traffic as the Higgs field. As you move through the traffic, you are slowed down. And the more that you interact with it, the slower you have to go. The Higgs field works in a similar way. As a particle moves through the field, it is slowed down. And it is this slowing down effect which gives the particle its mass. The more a particle interacts with the field, the more mass it has. Moreover, we should also know that the Higgs field doesn't eventually stop the particle. Rather, it just prevents it from accelerating. So now we know what everything in the world is made up of and how those particles gain their masses. So we must know about the origin of all mass, right? Well, wrong. Turns out that the mass we learned about is just 1 to 2% of our total masses. So where does the rest of our mass come from? Let me ask you a few questions. Which one do you think has more mass? This spring or this one? This ball or this one? As absurd as these questions sound, they do have an answer. And we get to that answer through perhaps the most famous equation of all time, Einstein's E equals mc squared. This equation literally tells us that mass is equal to energy divided by a constant. Which means that this spring, which has more potential energy, and that ball, which has more kinetic energy, have more masses. Similarly, inside the proton or the neutron of an atom, these quarks are moving around at very high speeds. So they have a lot of kinetic energy. And they have been confined into these small spaces. So they have a lot of potential energy. The sum of this kinetic and potential energy forms the remaining 98% of our mass. And that was the origin of mass.